In this lab, we'll investigate magnetic induction. Induction is a process that begins with a changing magnetic field. This field could be changing either because you have a moving magnet or because currents are changing. A changing magnetic field will, in general, mean that the number of magnetic field lines pointing through some surface will also be changing. This is called a change in flux through that surface. Anytime you have a change in magnetic flux through some surface, the loop created by the edge of that surface will have an EMF around it. If the loop is in a conductor, that EMF will cause a current to flow. Finally, this new induced current creates its own magnetic moment and magnetic field. This induced magnetic moment can then interact with the original changing field. We'll investigate the effects of that interaction in this lab when we drop magnets through conducting pipes and observe the effect of the induced fields on the magnet's motion. We'll also measure EMF directly, both induced by moving magnets and by changing currents. In the first part of the lab, you'll qualitatively observe induced currents. We'll generate a changing magnetic field by moving a small permanent magnet relative to a coil of wire. We'll do this for both 400 and 800 turn coils. The coil is directly connected to a multimeter set to measure current. What we'll do is place the magnet near the coils and then quickly pull it away so that the flux through the coils changes quickly. When you do this, you'll be able to see the reading on the multimeter change briefly. You'll relate the sign of this induced current to the direction and motion of the magnet. In the second part of the lab, you'll drop the same permanent magnets through conducting tubes. The induced currents in the tubes will generate magnetic forces that slow the magnet's motion. You'll measure the time it takes the magnet to fall through the tube and deduce the EMFs induced in the different conductors. In the last section of the lab, you'll generate your changing field by changing the current in a large set of coils. The current source is a power amplifier that's driven by an input from Data Studio. You'll measure the driving voltage on channel A of the data acquisition box. Channel B will measure the voltage across a smaller sense coil. We'll put the sense coil along the axis of the larger coils, so the changing field generated by the large coils will generate a changing flux in the sense coils.